My goal is that by 2021, I can live completely free of bills. Escape the illusion that in order to survive with luxuries of water, power, and natural gas must come at a cost of the working class dedicating the majority of our lives in modern-day financial slavery, in a grid designed to propel the already suited and keep us as simple working parts in a corrupt machine. In this series of videos, I will teach you how to disconnect financially from the grid 100% without having to sacrifice the energy we have undoubtedly become dependent on. Let me teach you how to harness the sun, the wind, the rain, and fire into everything from hot water to electricity. Thank you for watching My Free Life.
For the first step, I'll be making a stencil for the turbine blades. I am creating my stencil out of basic poster board sheets I purchased at Walmart for 33 cents each, bringing the current total to 66 cents for this build. When creating your blade template, there are a few things to consider. Like, are you wanting to create a fast set of blades for higher revolutions, depending on your particular turbine motor, or are you going for more torque? For my build, I am looking for more torque. So I'm going to make large blades. I'm looking to create a minimum of a 6-foot wingspan, not counting the hub diameter. So I will be cutting 3-foot blades. To achieve this, I'm taping together 2 sheets of this construction paper to allow for a 3-foot length, making sure to join the paper together with the true straight edge. After I have this step completed, I measure out 36 inches or 3 feet on both the top and the bottom end.
If you're enjoying this video, don't forget to like, subscribe, and hit the bell for notifications to keep you current on all my free energy builds. Thanks for watching.
Once I have my marks down, I use a straight edge to draw a cut line at my 3-foot linear mark, in this case, using a level. Now that I have my length drawn out, it's time to cut the paper down to size. Over the distance of 3 foot, I want approximately a 2.5 inch drop in width. So I measure up 4.5 inches on the left hand side of the stencil and 2 inches up on the right hand side of my stencil, using a straight edge again to draw out my cut line. Now I have the template for a 3-foot blade consisting of a 2.5 inch drop in the linear width. For my mill's blades, I will be using Schedule 40 PVC pipe, 1/4 inch thick with a 4.5 inch diameter. I purchased at Home Depot for just under $20, and I cut it down to a 3-foot length. Total project cost so far is $20.66. The next step is to transfer my stencil onto the PVC pipe, using a couple pieces of tape at each end. Now that I have my first blade marked, it's time to hit the garage to do the cutting. As you can see, I have no guard on my angle grinder. This is not the correct way to operate this tool. If you are inexperienced with power tools, never remove the factory safety functions or attachments, and always wear the proper PPE or personal protection equipment. In this situation, will consist of eye protection, earplugs, gloves, and even a full face shield. Alright, I have the first blade cut. Now, it's time to rinse and repeat for the remaining 2 blades. So FYI, this is how I look after the first cut. So, might want a mask on, something to cover all this, because you'll get all this if you don't.
If you're enjoying this video, don't forget to like, subscribe, and hit the bell for notifications to keep you current on all my free energy builds. Thanks for watching. Well, now I've got all 3 of my blades cut out of that, and I must say, wasn't dirty at all.
So the general idea for these blades will be a layout pretty much like this. That is, of course, after I figure out a hub assembly situation. I take a stroll through the neighborhood when I come across this baby stroller sitting at a dumpster. I thought to myself, well, there's a hub right there. So I bring it, hit the garage, back at the lab, and go to work. First, I remove one of the wheels for further inspection and haul it over to the neighborhood Home Depot to get some ideas. I'm a very visual person, so it's always best for me to create like this. First, I was thinking about mounting some sort of cross members to the rim, then mount the blades too. After further consideration, I thought perhaps that would be overkill and cause more drag than necessary. So I found these T-mounts that seem to be promising at $6 a piece, moving my current total to $38.66. Now I head back home to dismount the stroller tire from its rim, using a long screwdriver tip to place between the tire and the rim to peel apart. This looks like it can make a great hub, and it has great bearings, spinning flawlessly and effortlessly. Back to the blades. It's time to decide my mount layout. I first need to notch out the base of each blade to expose an arm to attach each bracket. I trace out my cutoff line using a mount as my stencil, repeating this for each blade. With your blades facing upwards and the wide side at the bottom, you will be marking and cutting out the lower right hand portion of each blade. They should look something like this. Back to the garage for these 3 cuts. Remember, safety gear before you begin this task. I have a bad habit of skipping safety precautions due to almost 30 years in the construction business. Don't be a Saxx. Take the time to always be safe. If you're enjoying this video, don't forget to like, subscribe, and hit the bell for notifications to keep you current on all my free energy builds. Thanks for watching. After getting my blade arms cut out, I head back to my office to configure the mounting points to the rim or hub in this application. I measure the rim to know the size grid for me to determine the proper points of attachment. After I determine my placement, I transfer those marks to the rim, a perfect triangle, to hopefully achieve balance between the blades. Now it's back to the garage to do some more work on the blades. I need to sharpen them so that they can cut smoothly through the air, reducing the friction. Using my angle grinder, I sharpen the downsides of each prop. Okay, it's time to attach the mounting brackets to the blade arms. I am first going to mark out the hole positions onto the blade. Now that I have it marked up, I'm going to drill out the holes. I'm only putting 2 bolts in each arm, making sure they're in opposing sides and angles. Too many holes would reduce the continuity of the PVC. When drilling out my bolt holes, I use a bit, which is a step down size from the actual bolt. This way, I can thread the bolt in and eliminate any play between bolt size and hole size. This package of nuts and bolts was approximately $3. Bringing my new current total to $41.66 on this build. After attaching the mounts to the props, it's time to drill out the mounting holes in the hub. I need to determine dead center of the brackets and mark, giving me a visual center guide to line up with the hub markings so that each blade will hold an equal distance.
If you're enjoying this video, don't forget to like, subscribe, and hit the bell for notifications to keep you current on all my free energy builds. Thanks for watching.
The holes are all drilled out, and it's time to attach the blades. The bolt heads I'm using are pretty small, so I will be using washers to ensure the bolts don't pull through while in spin. Be sure to use lock washers under your nuts so they won't want to back off. Now this is important. When mounting the third and final blade, make sure to position it in the down position. It will be opposite of the previous two blades. Alright, we're all mounted up. At this point, your project should be similar to this. Now it's time to take this part of the build into the garage to give it a basic spin test. To do this, I simply put the rim back in the stroller to see if it still spins freely with the large blades attached to it. Well, it seems to still spin effortlessly. So now, we need to dissect this stroller and turn it into a windmill. So, what do I know? I know I need this shaft to come out in order to incorporate the wheel's pre-existing lock-in pin setup. So I need to cut this section off. Again, make sure to wear all the proper PPE. If you're enjoying this video, don't forget to like, subscribe, and hit the bell for notifications to keep you current on all my free energy builds. Thanks for watching. This is where the wheel snaps into the stroller and locks in place. I need this. Here is that section removed and in the light. I left this tube mounted to the stem just in case I needed to assist in mounting my generator to. Not sure yet. I'm designing it as I go. This is a section of aluminum tubing I had in the shed, which at one point was part of a ski boat canopy. The size tube is just about the perfect size to create the tail fin arm with. I cut myself out a 3-foot section. This here is where I need to either take out or cut off. This way I can insert the aluminum rod and then notch out the size of the tail to insert my fan into that will control the direction of the turbine blades into the wind. Now that I have that piece cut and ready to insert the tubing, I move to creating my tail fin, using the same Walmart construction paper to make my stencil. I make my stencil 20 inches long and 16 inches wide. I come in 4.5 inches and mark my template on both sides. Then I go down the lengthways and mark 8 inches on both sides. Use a straight edge to mark my cut lines. Now I have the tail fin template done. I need some material to create it out of. I have this old beat up aluminum skin from my Airstream. I think I can make this work. Now that I have a section cut out, I need to transfer the stencil to the aluminum and cut it out. And remember, always use the proper safety equipment when operating power tools. As I'm sure you noticed, this skin is in bad shape, but I think we can fix that. Using a heavy hammer and a piece of 1x6, I pound out the dents. Okay, let's put together the tail assembly. My pipe is slightly too big to fit, so I'm going to bevel this end of the aluminum with my grinder. Alright, that ought to do it. I put the notches in for the fan. I cut my notches in with one cut the depth of my cutting wheel. That should be about perfect.
If you're enjoying this video, don't forget to like, subscribe, and hit the bell for notifications to keep you current on all my free energy builds. Thanks for watching.
The shaft fit in perfect, and now for the tail. I need to drill 2 holes, one on each side, slightly off-centered, to create a pinch point to keep the tail locked in place. Now it's time to test my build thus far. What I'm looking for is a good even spin and changing of direction to stay into the wind. I rig up a test pole by simply hammering in a fence rod and sliding over some PVC pipe to set my assembly into. Now remember, this is very temporary, just something to hold it up to see if it works. Today actually makes a great day to test this. Not real windy, but windy enough. I feel it should turn the large blades as well as show if the tail assembly is working. With light wind, the mill immediately comes into a spin and follows the wind great. With only a minor second of increased wind, the blades drastically speed up, so well that that's about all my temporary post is going to handle. For phase 2 of this build, I'll be constructing the actual post and making the generator, motor mount. I hope you enjoyed the video. Don't forget to subscribe, like, and turn on your notification bell to get the up-to-date builds on my free life.